So we understand from a density standpoint why less dense things float on more dense things. But what we really want to know is how those steel cargo ships float. How do these things float? With their immensely heavy boxcar containers full of cargo. There's no way. How do these things float? This guy here. Right? What the heck, right? What's going on here? That thing's heavy as all physics. How is that floating on the surface? It seems impossible, but enter Archimedes' principle, and it helps us understand how this works. When a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. That's the crucial part at the end. I'll repeat it. When a body is completely or partially immersed in a fluid, the fluid exerts an upward force, a buoyant force, on the body equal to the weight of the fluid that's displaced by the body. The upwards force on the ship is equal to the weight of the volume of fluid displaced by the ship. This means that the ship just has to be designed in such a way as to displace a volume of water that weighs more than the ship itself. And this can be accomplished by having a really wide, deep hole. H-U-L-L. The volume of water displaced can be much larger than the volume of your ship if it needs to be, and that's exactly how they do it. It's worth repeating Archimedes' principle a few times to yourself until it clicks, because it's a really simple and elegant answer to a question that would confound the average person. And it's a particularly fun question to go around asking people, your friends and family, and see what they think before you explain it to them. Just ask people, how do these things float? How do boats float? And see what the average person thinks. Because without Archimedes' principle, it really doesn't make any sense. But it's quite a simple and elegant explanation.